Hello everyone, welcome back to my YouTube channel. Today in this video, we are going to talk about Maharashtra State Board, Class 10, Science 1, Chapter number 8, Metallurgy. And this is a part 2 of this particular chapter. In a part 1 already we have discussed about the physical properties of the metals and the non-metals, chemical properties of the metals, reactivity series of the metals. These things already we have done in the previous part of the chapter, means in the first part of this particular chapter. So today in this part 2 we will start with the chemical properties of the non-metals. In that, the first what we have, that is the reaction of a non-metals with the oxygen. As we have already studied about the metals reacting with the oxygen and forming the metal oxide, same way when we talk about the non-metals, when they are reacting with the oxygen, then they are forming the oxides of that particular non-metal. And that may be acidic in nature, that may be neutral in nature, that may be some other alkali solution of the particular non-metals. So it depends which particular non-metal we are taking and which particular reaction we are discussing about. The next what we have to discuss is the reaction of a non-metal with the water. Reaction of a non-metal with the water, it produces the acidic solution. We are getting the acids mostly. Next is a reaction of a dilute acid with a non-metal. There also the acids are produced, the other acids more reactive non-metals are reacting and forming the other acids. Like here they have taken the example of the chlorine reacting with the hydrogen bromide. There we are getting the hydrogen chloride and the bromine gas is released, or the in an aqueous solution the bromine get dissolved. Then the reaction of a non-metals with a hydrogen, sulfur reacting with the hydrogen and forming the sulfur hydrogen sulfide, then the nitrogen reacting with the hydrogen and forming the ammonia. The next what we have to discuss is the ionic compounds. Ionic compounds, that in a previous standard already we have studied about. Whenever there is an exchange of the electron or the transfer of an electron from the metals to the non-metals, it produces the ionic compound. Means one of the metal transferring its electron or donating its electron to the non-metal, and due to that the charged ions are formed and then they are attracting each other. The positive and negative charged ions, they are attracting each other and that forms the ionic bond, and that particular combination of the atoms forms the ionic compound. In this particular section, the two important factors which are responsible for the ionic compound, that is the size of the positively and negatively charged ions, that decides what will be the structure of the crystal, and the magnitude of the electrical charge on the ions. Now the next what we have to study, that is the properties of the ionic compound. In this, the general properties of the ionic compound, the attractive force between the positively and negatively charged ions is a strong, therefore the ionic compound exists in solid state and are hard. The ionic compounds, when we talk about the ions, what is produced, that is a positive and negative charged ions, they are very strong in nature. Their bond is very strong in nature, and that's why the ionic compounds, they are mostly found in the solid state and they are hard. The next one is ionic compounds are brittle and can be broken into pieces by applying pressure. The intermolecular force of attraction is high in ionic compound and a large energy is required to overcome it. Therefore, the melting and boiling points of ionic compounds are higher. So their melting points and the boiling points are the higher due to the strong bonds present in them. The next is ionic compounds are water soluble. This is because the water molecules orient in a particular manner around the ions separated by a dissociation process. As a result of this, a new force of attraction is established between the ions and the surrounding water molecules, replacing the original intermolecular attraction, and hence The most of the ionic compounds, they are soluble in the water. The next property what we have for the ionic compound is the ionic compound cannot conduct electricity when in solid state. It's but obvious because their bond is very strong and they don't have any free ions among themselves. So it is a bad conductor when it is in a solid state. But as soon as we dissolve this into the water, the ions are getting separated, the ions are getting dissociated, and that's why they are conductive in the aqueous solution. Now here they have given the ionic compounds like water, the non-ionic, you can see the melting and the boiling point, zinc chloride, magnesium chloride, sodium bromide, potassium chloride, and the magnesium oxide. These all are the ionic compounds, and you can see their melting points and the boiling points. They are very high because they are the ionic compound and they have the strong bond between the atoms. Next, what we have to study, the most important part of the chapter, that is the metallurgy, the science and technology regarding the extraction of metals from ores and their purification for the use is called metallurgy. The extraction of a metal, that science, that technology is called as the metallurgy. Now, most of the metals being reactive do not occur in nature in free state because metals are reactive. So they are not found free in nature. They are found as oxides, carbonates, sulfides, and nitrates. So we have to purify them. We have to extract them from this ores. So that particular process is known as the metallurgy. The compounds, you can see here, the compounds of metals that occur in nature along with the impurities are called minerals. Okay, so this is a definition for the minerals. The compounds of metals that occur in the nature with the impurities are called minerals. The next what we have, the minerals from which the metal can be separated economically are called ores. So this is a definition for the ores. The minerals from which the metal can be separated economically are called ores. The next part what we have to study, that is the principles of metallurgy. We have a number of steps involved in the metallurgy process. In that, the first step what we have, that is the concentration of ores, because just now we have discussed about the ores are nothing but what, the type of a mineral in which the metals are present in a larger quantity, and we have to separate that metals from it. That is the extraction. That process is called as the extraction. Now in this particular process, the separating of the gangue from the ores is called the concentration of ores, because the larger quantity of the mud, soil, all this what we have, that we are removing first by washing it, and that process is called as the concentration of ores in a simple way. In that, we have various methods for the concentration of the ores, that based on the gravitation. The first one is a separation based on gravitation. In that, the first method what we have, that is the Wilfley table method. Wilfley table method is what? First of all, what we are doing, the ores what we are getting from the soil or from the rock, that we are grinding. After grinding it, it's poured on the trays, and this is a table like structure on which the slits are made. The slits, they are very important. They are a groove like structures, and this, along with the water, this grinded ores are supposed to pass over this particular slits table, and the table is vibrating continuously. And due to that vibration, what happens, the small particles, the heavy particles, because metals are heavy as compared to the soil and the mud, so they are getting sticked in this particular slits. They are getting stick in this particular slits, and with the help of a brush, it's continuously cleaned, means that metals are taken out, and the further the mud and the soil is supposed to flow down and fall on this. So that is nothing but what, the gangue. This is a Wilfley table method. The next one is a hydraulic separation method. Here also the same way, what exactly we have, the water is inserted in this particular tank. The water is inserted and the powdered ore is dropped in this slowly and slowly. As the metals are heavy, they will settle down. They will settle down here. And the light material, that is the impurities, that will come out from the top layer of the tank. You can see here the concentrated ore is getting collected at the bottom. The another method, we have the magnetic separation method. The magnetic separation method is useful for the magnetic materials. If the metal which we are extracting is a magnetic in nature, then this method is very useful. Again, the same way what we are doing, we are grinding the ore what we have, and that we are dropping through this funnel like structure. Now the further is, there is a magnetic roller. This is a magnetic roller which is functioning with the help of the electricity. The motor is connected to it, and this is a magnet we have. This particular roller what we have is a magnetic. So what happened in this case, this ore is dropped on this conveyor belt. This is a conveyor belt we have, like accelerators. We have a conveyor belt on it. So all the magnetic materials will get stick to this particular belt, and with the help of acceleration, inertia already we have studied. So this particular materials which are non-magnetic, they will be thrown a little far from the machine, right? And the magnetic material will get dropped down into the another collector. So this is useful only for the magnetic elements or the magnetic materials or the metals which we are extracting. The further is froth flotation method. The froth flotation method is based on two opposite properties, that is the hydrophilic and the hydrophobic of the particles. Here the particles of the metal sulfides, due to their hydrophobic property, get wetted mainly with oil, while due to the other, there is a hydrophilic property, the gangue particles get wetted with the water. By using this, the properties certain ores are concentrated by the froth flotation method. That picture they have shown over here, the froth flotation method, the froth is generated, and the froth, we have the sulfide ore, the concentrated sulfide ore comes out with the froth, because the froth which is getting produced, that is the oil like structure, and it's get attached to the sulfide ore. The next method what we have is the leaching. The first step in the extraction of a metal, aluminium, gold and silver from these ores is a method of leaching. In this method, the ore is soaked in a certain solution for a long time. The ore dissolves in that solution due to a specific chemical reaction. The gangue, however, does not react with this and therefore does not dissolve in the solution, so it can be separated easily. For example, the concentration of a bauxite, the aluminium ore, is done by leaching method. The leaching method is used. Here the bauxite is soaked in aqueous solution of the NaOH or aqueous solution of the sodium carbonate, that is Na2CO3, and that dissolves the main ingredient, that is alumina in it. Now the another what we have to study, that is the extraction of metals, in that the extraction of the reactive metals, especially how we are doing that, the metals at the top of the reactivity series are highly reactive. Their reactivity decreases down the series. For example, the potassium, sodium, aluminium are reactive metals. Reactive metals have large capacity to form cations by losing the electron in the outermost shell. For example, the reactive metals react vigorously with the dilute acids to give hydrogen gas. Highly reactive metals burn by reacting with oxygen from air at room temperature. Their extraction has to be done by electrolytic reduction. For example, the metals sodium, calcium and magnesium are obtained by electrolysis of their molten chloride salts. In this process, metal is deposited on the cathode while chlorine gas is liberated at the anode. The electrode reactions during the electrolysis of molten sodium chloride to get metallic sodium, or as shown below. You can see that the reaction they have shown over here, that is the cathode reactions, that is Na ion, that is sodium ion, is reacting with the electron and forming the sodium reduction, and the anode reaction, that is the chlorine, is forming the chlorine gas and the electron is released, that is the oxidation reaction. So this is called as the electrolytic reduction of aluminum oxide, called as the bauxite. So this is all about this particular video. In the next video, we are going to talk about the extraction of the aluminium, how the aluminium is extracted, and some more things related with the metallurgy.